Hello everyone. In this video, we will work with finding the moment of inertia of a solid of revolution. The formula to look for the moment of inertia for the solid is given by Iy, okay, with respect to the y-axis, Ix with respect to the x-axis. So for finding Iy is equal to 2 pi rho, and the integral from a to b, x to the exponent 3, y2 minus y1 dx. As you see that in working with moment of inertia, we were talking about using the element that is parallel to the axis of rotation. In terms of the solid of revolution, if you are using the element that is parallel to the axis of rotation, then we are talking about the shell method, right? Because we are talking about volume in this case. So the moment of inertia of a solid of revolution is found using the shell method. In sketching the area, the element which is used is parallel to the axis of rotation. Okay, so again the same thing to find r is a square root of I, y, like the moment of inertia with respect to the y-axis divided by the mass. And the mass in this case will be equal to rho times volume. Okay, and the volume that you need to find in this case is using the shell method. So to find the moment of inertia, we are talking about volume using the shell method because the axis of rotation is parallel to the element that we are going to use. Alright, so I have the formulas here to remind everyone about the shell method. So with the shell method, this is your vertical element, which is dx. You have to take x times y, okay? Y is a function in terms of x. And if you are having the axis of the rotation is the x-axis, then your element could be horizontal, which is parallel to the x-axis. And in this case, volume will be equal to 2 pi multiplied by the integral from c to d, which is your dy, okay, upper and lower limit, and y times x, and x is the function in terms of y. Alright, so let me illustrate this on the diagram for everyone so that you visualize how the formula is supposed to work. Alright, so first of all, I have the x and y axis. Okay, so x and y axis. And because I'm having this element that I drew for everyone, and is parallel to the axis of rotation. So I'm going to draw, this is my y-axis, right? So this is my Iy that I have to find. That means my dx. Okay, so don't forget the moment that we are talking about is the square of all the moment. So that is my x squared. So this is from a to b. So the upper and the lower limit will be on the x-axis. So the most important thing I want to emphasize to everyone is the element is parallel to the axis of rotation. And in finding volume, if you are using the axis of rotation, and then you are choosing the element that parallel to that axis of rotation, then you have to stick with the shell method. Okay, so then volume is equal to 2 pi from a to b of x times y times dx. Okay, so again, it's a shell method. Now, let me substitute it into the formulas for everyone to see. So I, y, now equal to, because you have the 2 pi here, so you have 2 pi rho. So now you know why you are having 2 pi times rho. The integral from a to b, and I'm going to take x, and y in this case will be my y2 minus y1, okay, and times the x squared times the dx. So now I'm going to combine these two. Therefore, the formulas I have for Iy should be equal to 2 pi rho, the integral from a to b, and then x to the exponent 3, y2 minus y1 dx. And don't forget, y2 is your upper function and y1 is your lower function, and you can identify your upper and your lower function by shading the area, and keep your eyes within that area to identify your upper function and your lower function. Alright, okay. So this formula representing the axis of rotation is the y-axis. So here is axis of rotation is y-axis. Axis of rotation is y-axis, but you are using dx because you are using the element that is parallel to the axis of rotation. Okay, so the similar approach for this, if I am using the axis of rotation as the x-axis, okay, so this is my I-axis. So in this case, this one's supposed to be my dy, and here from C to D, and the square of the moment. Alright, okay, so that means the volume in this case will be equal to 2 pi. So let me write it down here. Yeah, okay, so volume is equal to 2 pi from C to D, right? So y times x times dy, because everything need to be in term of y. So this one is the shell method. And then I am using the horizontal element, right? So horizontal element, so this one is parallel to the axis of rotation, which is the x-axis. So my element is parallel to the x-axis. Alright, okay. So now I'm going to put in the formulas for Ix. Okay, so now it's 2 pi rho from C to D, and I will have y, and then the right function subtract the left function, and y squared dy. Now combining these two, okay, I should have Ix equal to 2 pi rho from C to D of y q, and then x2 minus x1 dy. Alright, okay, so don't forget that in order for you to recognize the left and the right function is to shade in the area that you are working with. In shading the area that you are working with, you can recognize which one is your left and which one is your right. You have to take the right function, subtract the left function in this case. Okay, so let's draw that. So if I have an area like this, okay, I should draw it like this. Then I shade in the area, and then here's my horizontal element, touches both curves, and I have to take the right function, subtract the left function. Okay, so this will be my x2 and this is my x1. Okay, don't forget that. This is the left, this is the right. Sorry, I mixed up between the two. So this is your right and this is your left. Okay, always take the right one, subtract the left one. Alright, so this is the formula for the Ix. Okay, and this is the formulas for the Iy. Okay, however, I can mention to everyone that in designing any solid that you are going to work with, it's entirely up to you to choose your axis of rotation. Okay, so you can choose the axis of rotation as the y-axis or the axis of the rotation as the x-axis. However, in working with the solid and to calculate the moment of inertia, most of the time that we see that everyone choosing the axis of rotation as the y-axis. And in that case, easier for you to use your vertical element. Okay, so I'm going to go over an example that working with the solid, and we are going to use the axis of rotation as the y-axis. Alright, okay, so let's work with this. Okay, so I'm going to find the moment of inertia, and in this case is the, so in this one I have to find Iy, okay, and I also have to find Ry, and Ry is equal to square root of Iy divided by the mass. And don't forget, the mass in this case is the rho times the volume. And the volume, we are going to use the shell method. Okay, so these are very important. So now, first of all, like we said, we are going to shade in the area that we are working with. So they ask us to find bounded by the first quadrant, okay? The first quadrant, therefore, is very important that we are working with y equal to 4 minus x squared. So the first quadrant will just be this. Okay, so I'm going to shade in the area that I'm working with. And I'm going to draw the element that parallel to the axis of rotation, which is the y-axis. So this one is easy. I just have to take the upper function minus the lower function. So within the green area that I shaded for you, the upper one should be your parabola. So it's simple as that. Okay, so the parabola will be your y2 equal to 4 minus x squared. I said it's simple because I kind of create that simple rule for everyone to remember. I tend to have a very simple approach to calculus. Okay, so for finding the area in here, we need to take the upper function minus the lower function, and to recognize upper and lower is to shade in the area. So that's why I'm asking everyone on the test that you make sure that you shade in the area for me, right? So in the process of shading the area, you probably realize that what is your upper function and what is your lower function. So now it's very obvious your lower function should be this line right here, which is your x-axis. And what is the equation for your x-axis? Is actually y equal to 0. So I can identify y1 is equal to 0. So now you see we have to analyze, and we are going to put everything into the integrand to integrate. Right? Alright, okay. So let me correct this. Alright, okay. So the next step is to write down the formula that we have to work with. So I'm working with the Iy equal to 2 pi rho and the integral from a to b of x cubed y2 minus y1, and we figure out our upper and lower function already. Okay, so the next step is to find the a and the b. So the a right here obviously is equal to 0, right? For this one here, you need to find that. In order for you to find that, I'm going to let y2 equal to y1. Okay, so I'm going to let y2 equal to y1 to find my upper limit, which is the b. Okay, so doing that, you should have 4 minus x squared equal to 0. So that means 4 equal to x squared, right? You bring the negative, subtract x squared, bring it to the other side, become plus x squared. So you will have the x will be the square root of plus minus 4. So you should have plus or minus 2 as a value for x. But we are going to ignore the negative value here because we only work with the first quadrant, right? So therefore, this point on the graph should be 2 and that one should be 0. So your upper and your lower limit is 2 and 0. Okay, very simple. So the next step is to substitute it into our formula to find our IY. 2 pi rho, and remember these are all constant here, right? So it's across the integral sign. 2 is a constant, pi constant, rho is a constant as well. It's the density of the material that you're going to use to design your solid. So 0 to 2, x to exponent 3 multiplied by 4 minus x squared times dx. Okay, so let's simplify this by multiply x to the exponent 3 into the bracket or distribute the term. So this I should have 4 x to the exponent 3 subtract x to the exponent 5 dx. Okay, simplify your integrand and now you can integrate. Now IY will be equal to 2 pi rho, and what I have here is the integral of 4x to the exponent 3 will be 4 over 4x to the exponent 4. 1 over 5 times x to the exponent 5 is the integral of x to the exponent 5. I'm sorry, I should say to the 6. Okay. Plus 1 divided by the result, right? So I should have 6x to the exponent 6. Okay. Sorry, I think it's because I'm fighting a cold and a sore throat. So whenever you don't feel well, I don't think it's good to do mathematics. Okay. Make sure you drink a lot of tea. I did, but it didn't help in this case. Alright, so now let's work with the fundamental theorem. So it will be 2 pi rho, and I should have f of 2 minus f of 0. So I keep repeating this step because I just want everyone to analyze your solution at the same time as you are working with it. So now f0 is equal to 0, so you can ignore that term because x is present in each of these terms right here. So let me double check before I substitute the number in. So 2 pi rho, yeah, here should be 4 over 4 x to the exponent 5, so I should have 1 over 6 x to the exponent 6. So now, okay, I should have this as IY equal to 2 pi rho, and then 2 raised to the exponent 4, because I just have x to the exponent 4, so 2 raised to the exponent 4 minus 1 over 6 of 2 raised to the exponent 6. So it's 2 pi rho, and I should have 16 subtract 64 over 6. Therefore, my should be 2 pi rho, okay? And then I can have here as 96 subtract 64. So it's easier to use a calculator if you can just go ahead and use your calculator and figure this out. But what I'm going to do is I want to simplify the 2 with that. I should have a 3. Then I should have 32 pi rho divided by 3 as my IY. Alright, okay. So after I got IY, I am going to find the mass so that I can find the IY. So for the mass, I need to write the formula down. So it's 2 pi rho multiplied by the volume. Alright? So the volume here is the shell method. So then it's equal to 2 pi rho integral from 0 to 2 of x times y times dx. Alright, okay. And mass is equal to 2 pi rho, the integral from 0 to 2 x, okay. The y in this case is 4 minus x squared. Alright, so there's dx. So I should have is 2 pi rho integral from 0 to 2. I'm going to multiply this inside the bracket. I should have 4x subtract x to the exponent 3, and there's dx. Okay, so now we can go ahead and integrate. Okay, so integral of 4x is 4 over 2x squared. Integral of x to the exponent 3, add 1 to the exponent divided by the result. So 1 over 4x to the exponent 4, 0 and 2. So my next step is to identify my f of 2 subtract f of 0. So this one should be 0. So you can go ahead and forget that. And mass is equal to 2 pi rho. Now I should have 2 times 2 squared subtract 1 over 4 times 2 to the exponent 4. Okay, very nice. Okay, so 2 pi rho, and then I should have 8 subtract 4. So in this case mass is equal to 2 pi rho, and then I multiply this by 4, so it should be 8 pi rho. Alright, okay, so now substitute into our formula of Ry. So Ry equal to the square root of Iy divided by the mass, and the mass is the volume in this case, so it's the square root of 32 pi rho divided by 3, and I have to divide that with 8 pi rho. Okay, so again we have to watch out for our algebra. So 32 pi rho divided by 3 multiplied by 1 over 8 pi rho. So let's cancel the term. Now you see the pi and the rho disappear, and you can cancel the 32 with the 8, so that should give you a 4. So Ry equal to the square root of 4 over 3, right? Okay, now simplify and leave your answer as the exact result. So it will be root of 4 divided by root of 3. So it will be 2 over root 3. Now, because it is a radical, we cannot have the denominator as the radical, so we need to rationalize the denominator. So I multiply the top and the bottom by root 3. So then my answer will be 2 root 3 divided by 3 as my final result. Okay, so what we are going to do next is I would like to I have a few minutes, so I want to go over what we have done. Alright, okay. So for a solid, again, like I said to everyone, you are designing your own solid. So it's best that you chose the axis of the rotation most suitable for the solid that you are going to use. So in this particular lesson, I only concentrate on the axis of rotation as the y-axis. Okay. So for the y-axis, this is the formula that we have to use, and we are working with everything in terms of x. And the element we are going to use will be parallel to the axis of rotation. So in this case, it will be the vertical element. And most of the time, vertical element is a lot easier to work with than the horizontal element. Okay. So especially if you have to identify that with the washer method as well. Okay, so with the washer method, don't forget that we concentrate on the vertical element only. So using the formulas that we are working with, we have to figure out the upper and the lower limit in this case. So everyone remember the algebra with the quadratic formulas, or solving for the pure quadratic in this case. And we ignore these values because we only work with the first quadrant. Okay, and then substitute them into the equation to integrate. And to find the mass, don't forget in previous example, our mass will identify by the rho times the area. But because the mass, now that we have to use volume, will be 2 pi rho's times volume using the shell method. Because shell method associate with the element that is parallel to the axis of rotation. So that is the only method that you can use in this case. Alright, okay. So using the shell method, then we have the formulas for our volume, which is these formulas. And then the x is always there, but your y is the function y in terms of x. Substitute your function y in terms of x into here, expand, and then integrate. After you find the mass, you can see that the pi rho is there. And if you substitute into this equation, you see the pi and the rho will cancel itself out. Alright, so we answer all the questions that they asked us to find. Our Ry will be equal to 2 times root 3 over 3, which is the simplified and exact answer. So I want to emphasize that it's simplified and exact. Okay, exact means you must leave your answer as fraction. You cannot have it as the a decimal. To simplify means that if it is the radical, then you need to rationalize the denominator. It means that you cannot have the radical as a denominator. And simplify as a fraction, that means your fraction has to be in lowest term. Okay, so that's the Ry that we found. Before we can find Ry, we find the mass, but mass associated with volume in this case. Okay, and volume is a shell method. And the Ry that we figure out is also in the exact and also in lowest form as well. Okay, simplify and exact in lowest form. Alright, thank you. And just want to remind everyone that I have quite a few questions for you to work with. I have 3 questions, and the solution is actually posted online. Alright, thank you.